Hello everyone. In this video lecture, we are going to understand the Prim's algorithm that is used for finding the minimum spanning tree. In the last video lecture, I'll explain you what is a spanning tree of a graph and also what is minimum spanning tree. Basically, there are two algorithms for finding the minimum spanning tree. One is Prim's algorithm and another one is Kruskil's algorithm. In this video lecture, we are going to understand what is Prim's algorithm and how to find the minimum spanning tree of a particular graph, right? So, let me take one graph. Let us say I'm having this A, B, then C and D and E. I'm just joining it randomly. So along with I'm giving the weights as well, right? So then I'll explain you. This can be 4 and this is like okay 11, right? So yeah, this is the graph given to me, right? And I want to find the minimum spanning tree. Now it is very tedious to go with the basic things, as I shown you in the previous lecture, that we can find all the possibilities, all the spanning tree, and then we need to calculate the total cost, and after finding the total cost we need to select which one is having the minimum total cost. That would be my minimum spanning tree. Now that is a tedious task. Along with that, if I have a big graph, then it takes a lot of time and it might be possible that I might miss the actual spanning tree which is having the minimum cost, right? So we go with this Prim's algorithm. Now it has a particular steps, right? So step by step I'll explain you. What you need to do is, first you need to select the starting vertex, right? Now this is a general one, so I can take anything as a starting vertex. I can consider A as a starting vertex, I can consider C as a starting vertex, E, anything, right? In an examination, if it is given to you that your starting vertex is B, then you have to start with B. If it is given that starting vertex is A, then you need to go with that only, right? So here I am considering A as my starting vertex, right? I'm just writing over here that my starting vertex is A. In examination also, if you're choosing by yourself only, so you can just write it down, make a note that my starting vertex is this, right? So I have already selected my starting vertex. Now what I need to do is I need to find all the adjacent vertices, right, and add it as a fringe vertices, right? So what I'm doing over here is I'm just making a fringe vertex, that here I have a B and here I have a C, right? Now out of this two, I need to consider the weight, right? So here the weight is 7 and here the weight is 3, right? Now we need to check which one is the minimum, right? So here, as you can see, that 3 is minimum, right? So I have selected, we need to select an edge which is having the minimum weight. So in this scenario, C is having the minimum weight, so I'll just select this vertices, right? And now my C is reachable, right, with the weight 3, right? So now the C has been added to my spanning tree. Now again I need to check, right? What I need to check is that along with the C, that this A is here, this is done, right? This is still a fringe. Now I need to just check the adjacent vertices of C, that is the fringe one I did to add it, right? So C, so here I have a D that is having 10, and also the B that is having 4. Now see, I told you earlier as well, for finding the minimum spanning tree, you need to keep in mind that cycle should not be there. Yes, it is correct, but here you might think that I have connected this and this will generate a cycle. No, here these are the fringe water. I have not yet selected it, right? Now I need to select from the 7, 4 and 10 which one is minimum. So as you can see that here 4 is minimum, so I can select this 4 and add it to my minimum spanning tree, right? So now in the next step I need to go with the B, right? All the connected vertices with the B. So this A I have, then this C is already done, this B is already done. Now see, I'm just not adding this fringe over here, right? This fringe I'm not adding for the 7, right? Why? Because B has been already selected via C, so I don't need this edge for connecting B, otherwise it will generate a cycle, right? Now I need to add the fringe, right? So here this C that is for the D, and that's a 10. Here it's a 9, and B connected with E, that's 11, right? Now out of this 3 you need to check which one is minimum, right? So as you can check that 9 is minimum, right? So I need to just select this 9, right? This I need to add this vertex D along with the edge to my minimum spanning tree, right? Now as you can see here that A, B, C, D, right? These 4 vertices are in the my minimum spanning trees. Till now E is remaining, right? So if I go next, so this A is here, C is here, B is here, D is here, this 9, 4, 3, right? Now D is already visited, so this fringe also I don't need, so I just remove it, right? Now if we talk about E, so there is only one fringe coming towards the E, right? There is only one edge, right? So B is connected to E only, right? Nothing else. So I'll just select this, and this is 11. Okay, right? So my final minimum spanning tree would be this A to C with the weight 3, towards the B with the weight 4, towards the D with the weight 9, and towards the E with the weight 11, right? Now if you find the cost, you just need to sum up all this, right? So that's a 4 plus 3, that's a 7, 7 plus 9, that's a 16, 16 plus 11, that's a 27, right? So for this tree the cost is 27, and this one is your minimum spanning tree. You can try, like if you want to cross verify, you can go with the other spanning tree as well directly without using the Prim's algorithm, because via the Prim's algorithm only this you can get, right? And you can check the minimum cost, this will be only there, right? So in a Prim's algorithm, what you need to do, it's very easy algorithm. First you need to choose the starting vertex. I'm just giving you a brief about it. So you need to just select a starting vertex, right? Then Adjacent vertex you need to select and add a fringe to it, right? And whichever edge is having the minimum weight, that you need to select and add to the minimum spanning tree, right? And then again you need to follow the same step only. Again you need to go with the adjacent node, add the fringe to it, and which one edge is having the minimum spanning tree you need to select. These things you need to do it until all the vertices are reachable, right? For the spanning tree, two condition must be there, that all the vertices should be reachable, right? Must be reachable actually. And you should not have a cycle, right? If you have it might be possible that during that you will find an edge that is having a minimum weight, but if it generates a cycle, then you just need to skip it, right? And you need to go ahead with the next edge, right? So yeah, that's it. This is Prim's algorithm for finding the minimum spanning tree. In next video lecture we are going to learn about Kruskal's algorithm. So I hope you understood it. Thank you for watching this video.